Algebra 2, Chapter 7, Review 2. Review 1, answer key, you can find it on my website, and email me if you want me to do any of the problems off of that. Alright, so the first thing you have to do is always find your perfects. What perfect goes into 490? So you want to get your perfects sheet. And we're doing square roots. So what square root right here goes into 490? If you don't know, take 490 divided by 81, 64, 49, and so forth down. Hopefully you see that 49 goes into it. So you bring down your -2, and 49 times what gives me 490? 10. What is the square root of 49? 7. When it's next to each other, it means multiplication, so it's still -2 times 7 times the square root of 10. -2 times 7 is -14 square roots of 10. So now we have the cube root of 54. The cube root of 54, so we're looking at our cubes. Which of these go into 54? So this is too big, so you go 27, and 27 goes into it. How many times? 27 times what gives me 54? Times 2. A to the 11th, b to the 15th. First thing we have is the cube root of 27, which is 3. The 2 is going to stay underneath. And now groups of 3 have to leave. We have 11 A's, so how many groups of A's can leave? So 11 divided by 3 gives you 3. A, 3, and our remainder is going to stay underneath. And then we have 15 divided by 3 is 5. So 5 groups of B's can leave, and what's remaining stays underneath. Our 2 is remaining. We had 9 A's leave, so 9, 10, 11, so we have 2 A's left. And we had 15 B's, 5 groups left, so that means 15 B's left, so that is our answer. And because this is cubed, we don't have absolute value, so we're done. Whenever you can reduce first, always reduce. So you have 200 divided by 5. That gives you, so go in your calculator, 200 divided by 5. Hopefully you got 40. So what perfect goes into 40? So, and we're doing square roots, so we're looking at 4, 9, 16, 25, 36. So 4 goes into 40. 4 times 10 gives me 40. The square root of 4 is 2. The square root of 10 stays underneath because it's no perfect inside. Alright, number 4. Always reduce. So ask yourself, does 48 divide by 8? Yes. How many times? 6. If you have 7 x's on the top and you have 1 on the bottom, if you take 1 off the bottom, you have to take 1 off the top. How many is left on the top? 6 of them. What does the top or bottom have more y's? So we have 8 on the top, 10 on the bottom, so the bottom has more y's. So how many more y's does it have? 2. So we have y squared. This is still under the square roots. So now we can take and see what we can do. The bottom, if we take the square root of y squared, that's y. On the top, we have the 6 doesn't have any perfects, but the x to the 6th can come out. Remember, there's, what number is here? A 2. So that means that groups of 2 leave. So we have 6 underneath. How many groups can leave? 3. So we have x cubed, and then we have the square root of 6. Now, because these were square roots, technically we should have absolute value signs around those. So if you remember that, that'd be great. If not, it's okay too. But because this is a square, remember, even ones, when they come out, they should be absolute value because they have to be positive. You can, cubes and odds you can have, but since if it's a square root, 4th root, 6th root, those are supposed to come out with absolute values. But again, absolute values are the more advanced. Alright. The square root of 11x squared times the square root of 11x squared. Well, you can do it a couple of ways. I know the answer is 11x squared, because if you have 2 of the same thing, you multiply it together, then you're going to have a perfect square, right? But if you need to, you can always go 11 times 11, which is 121, and what's the square root of 121? Is 11. And then x to the 7th times x to the 7th is x to the 14th. And then how many come out? And I messed up on that. That should be a 7. I don't know why I put a 2. But x to the 7. Because it's the same thing. Alright. Here, again, reduce first, but you can multiply across and then we're going to reduce. So we go 5 times 1 gives me 5, since it's under both of them are under the same exact square root. So we got 5 times 1 is 5, 2 times 40 is 80, and then we're under the square root. 5 goes into 80 how many times? 16. So we have 5 goes into 5 once, 5 goes into 80 16. And now remember, it's the square root of each one. So the square root of 1 is 1. The square root of 16 is 4. Alright, number 7. Number 7, we have, first thing again is to multiply them. So we have the cube root of 12 times 3, which is 36. X to the 6th, x to the 7th is x to the 12th. And now we have to see is, does 36 have a perfect cube inside it? So we're looking at our cubes and asking ourselves, does 8 go into 36 evenly? Does 27? Well, 27 is too big, so does 8 go into 36 evenly? If you don't know, take a calculator and go 36 divided by 8. And it's 4.5. So since it's 4.5, that's answer is no, it doesn't. So there's no perfects in there at this time. So we leave that alone. But we can take out our x's. So 3 you have to leave at a time. We have 12 of them. So how many groups can leave? 4. So we have x to the 4th. And then the cube root of 36. Because it's the cube root, there's no absolute value signs, so we leave it like that. $81. And we're talking cube root. So what perfect cube goes into 81? Well, 64 is too big. So let's see if 27 goes into it. So we have 81 divided by 27. 3. So that means that 27 times 3, and then I bring down a to the 13th, b to the 24th. What is the cube root of 27? 3. This 3 is going to remain underneath. 3 have to leave at a time. We have 13, so how many groups can leave? A to the 4th. If 4 groups can go. We have 24 B's. How many groups of B's can leave? So you take 24 divided by 3. We get 8. Again, this is cube root, so we don't have to have absolute value signs. So this 3 stayed under. 12 A's left, so we have 1 A left. 8 times 3 is 24, so we do not have any more B's, so that's our answer. When we are combining radicals, if they look alike, if the same square root, then we can combine them. So we have 7 minus 1, because we have 7 of them, and we're going to subtract 1 of them, so we get 6. They're not the same, but we have to see does this have a perfect in it? 5 is the smallest it can get. But what about 20? Does 20 have a perfect in it? Remember, our perfects are right here. 4, 9, 16. So 4 is a perfect. So 4 goes into it. I'm done. 3 square roots of 5 plus 2. And it's 4 times what gives me 20? 5. So we have 3 square roots of 5 plus 2. The square root of 4 is 2 square roots of 5. And remember, when it's next to each other, that means multiplying. That's why these are being multiplied. So we have 3 square roots of 5 plus 4 square roots of 5. 3 and 4 is 7. So our final answer will be 7 square roots of 5. Alright, what do you notice about number 11? Hopefully you notice that it's the same thing but opposite signs. So what happens when we have the same thing but opposite signs if we FOIL? The middle two numbers will drop out. So what we're going to do is we're just going to do, since the middle two numbers on FOIL are going to drop out, we're just going to do the first and last. And if it's not the same, it doesn't. If it's not the same and has the opposite signs, because the opposite signs, one positive, one negative, that's why they cancel. But since we would have to do all of them, but we can just do the first and last. So we have 8 times 8, which is 64, and then we have a negative and a positive is a negative. 2 times 2 is 4. Square root of 3 times square root of 3 is the square root of 9. Now, just like over on 5, I could have said, because the square root of 3 and the square root of 3 is the same, I knew that the answer is going to be 3. But I decided to do the square root of 9 so that we can go break it down more. So 64 minus 4 times square root of 9 is 3. So in your calculator, go 64 minus 12, and you should get 52. What does this square mean? This square means that you have to take it twice. So that means 7 minus 2 square roots of 3 times 7 minus 2 square roots of 3. Now we FOIL. So the 7 is going to go here. So 7 times 7 is 49. Then we go 7 times the negative 2 is negative 14 square roots of 3. Then take your negative 2 times my 7, negative 14 square roots of 3. And the last, negative and negative is a positive. 2 times 2 is 4. Square root of 3 times square root of 3 is the square root of 9. So we have 49 minus 14 and 14 is 28. Square roots of 3, because these are like terms. And then we have 4 times my 3. That's 12. So 40, so this is 12. So 49 plus 12, 61 minus 28 square roots of 3. Alright, number 13. This means multiplication, so that means you have to distribute. Whenever there's a number out there, you have to multiply it to both. So, the square root of 6 times 2 square roots of 10. Remember, the square roots are what you multiply. So this is 2 and the square root of 60. Minus 9 times the square root of 6. The square root of 60 breaks it down into what goes into 60, what perfect. So you have to go and say, does 2, 9, 16, divide those out, see what they are. And hopefully you get 4. 4 times what gives me 60? 15. Minus 9 square roots of 6. The square root of 4 is 2, so we have 2 times 2 square roots of 15 minus 9 square roots of 6. 2 times 2 is 4 square roots of 15 minus 9 square roots of 6. Alright, when you have two numbers on the bottom and you want to get rid of that square root, what do you have to multiply it by? You have to multiply it by the same thing but opposite. So we have 1 and the square root of 5 and positive, so this is negative. So whatever you do to the bottom, you have to do to the top. So you have 2 times 1 gives me a 2. 2 times a negative square root of 5 is, remember there's a 1 right here, so it's 2 times negative 1, which is a negative 2 square root of 5. On the bottom, we have 1 times 1 gives me 1. And then 1 times a negative, square root of 5 would be the square root of 5. And then this is positive square root of 5, so those cancel. So then we have square root of 5 times the negative square root of 5, which is negative 5. Remember, because this is negative square root of 25, and 25 square roots is 5. Then we have here, on the top we have 2 minus 2 square roots of 5. On the bottom, we have 1 minus 5, which is a negative 4. Now, two things. First, we don't want a negative on the bottom. So we want to divide everything by a negative. But also 2 goes into all 3 spots. It has to be all 3 spots. So you have dividing everything by negative 2. Negative 2 divided by, or 2 divided by negative 2 is your negative 1. This is negative 2 divided by negative 2 is plus 1 square roots of 5. And then negative 4 divided by negative 2 is 2. Now, if you got to this point right here on your test, I will accept it. But this is the more advanced. Being able to reduce by what you need to reduce by. Alright, can't have the square root on the bottom, so we have to do what? We have to multiply the top and bottom by the square root of 13. So 2 times the square root of 13 is 2 square roots of 13. Square root of 13 times the square root of 13 is 13. 2 doesn't go into 13, so we're done. Alright, how can I get rid of this square root? I have to square both sides. So I'm going to square both sides. This cancels, so I have 2x minus 1 is equal to 6 squared, which is 36. So then you would add 1 to both sides, and you get 2x is equal to 37. Divide by 2, x is equal to 18.5. So, what do you think we have to do for 17? We have the square root that we want to get rid of, so we're going to square both sides again. Remember, the opposite of square is square root, so those cancel. So we get 3x minus 1. This cancels with that. So it's equal to 4x minus 7. Subtract the 3x from both sides. We have negative 1 is equal to x minus 7. Add 7 to both sides. We have 6 is equal to x. Alright, 18, we need to get our square root by itself before we can take the square, so we have to get rid of this. So we have to add 2 to both sides. So we have the square root of x plus 4 is equal to 12. And now we have to square both sides. Square roots cancel with the square. We have x plus 4 is equal to 144. Subtract 4, x is equal to 140. Alright, so the square root of a negative number is I. So we have I square roots of 48. Now, 48 can be broken up into what perfect? So what perfect of square roots go into it? We have 4, 9, 16, 25. You always want the biggest number. So 16 goes into it. So we have I square roots of 16 times 3 The square root of 16 is 4, so we have 4i square roots of 3. Now this a plus bi, that just means that they want their reals first and then bi. So we have the square root of a negative is I, square roots of 49 plus 6. Square root of 49 is 7, so we have 7i plus 6. But 6 is our real number, so you just have to rewrite it. So you have 6 plus 7i. This negative here is like saying negative 1. So you're going to distribute it to each one of them. So you have 8 minus 2i. Negative negative is a positive 6. Negative and negative is a positive 3i. Then just combine like terms. So 8 plus 6 is 14. Negative 2i plus 3i is 1i. So you can leave it like that, or 14 plus I. Now think of, when you're combining like terms, think of I as like an x if you need to. Negative 2x plus 3x, so you're combining like terms. See how this is 22 is a plus? You just combine like terms. So negative 5 plus 8 is 3. 3i plus a negative 7i is a negative 4i. (23) we have here 2 times negative 3 gives me a negative 6. Then we take this 2 and multiply it here, so you have 2 times negative 7 is a negative 14i. Negative 3i times negative 3 is a negative 9i. And then you take this times this, so you have 3 times a negative 7 gives you a negative 21. And I times I is I squared. What does I squared equal? I squared equals negative 1. So we have, let's combine like terms that we have. So we have negative 6, negative 14 minus 9 is negative 23i. And then we have a negative 21 times negative 1. So this makes it positive. So we have negative 6 plus 21. I'll write it for you. Negative 6 minus 23i. Negative 21 times negative 1 is plus 21. Oh, thank you. So we have 21 minus 6 is 15 minus 23i. Alright, 3 more to go, guys. 3 more. Alright. 24. We have 2 numbers on the bottom and we want to get rid of that I. So we have, and how can we get rid of that I? We need the middle 2 to drop out. So we have to multiply it by the same exact thing. Negative 3 and 7i. But instead of a negative, we want a positive. Now if you want to, FOIL this out and see that the middle 2 is going to drop out. But they will. So you have here negative 3 plus 7i. So the first thing we have is we take this top number and we multiply it. So we have 2 times negative 3 is a negative 6. 2 times my 7i is a positive 14i. Then we take our 3 and we have 3 times a negative 3 is a negative 9i. And 3i times 7i is 21i squared. On the bottom, let's FOIL it out just to show you. We have negative 3 times negative 3 is 9. Negative 3 times my 7i is a negative 21i. Negative 7i and a negative 3 is a positive 21i. Negative and a positive is a negative. 7 times your 7 is 49. I times I is I squared. So negative 7i times 7i is 49i squared. Negative. Now, see up here where this was a negative, and now by multiplying it, it changed the sign, right? So you can, I'm going to take this negative, or I squared, and remember that's negative 1. So 21 times a negative, that makes that a negative. So if I take this I squared, what does this become? Negative 49 times negative 1. Positive. So that we can combine like terms. See how these dropped out? Because this was negative, that's positive, that's gone. So on the top we have negative 9 minus, or negative 6 minus my 21, which is a negative 27. And then we have 14i and minus 9, which is your 5i. And I found another, I didn't finish this up on my key. So then 49 and 9. So you have 49 plus 9 gives me a 58. Alright, and that would be our answer. Alrighty, last, or almost last, we have here, this square means that there's two of them. So we're going to multiply negative 3 plus 5i times negative 3 plus 5i. Negative 3 times negative 3 is 9. Negative 3 times my 5i is a negative 15i. Inner, we have 5i and a negative 3i is a negative 15i. And last, we have 5i and 5i is 25i squared. Again, remember, what is this? I squared is a negative 1. So 25 times negative 1 is a negative 25. 9 minus 25 is negative 16. Negative 15i and a negative 15i is a negative 30i. And that's our answer. And last, actually no, almost last, we have 12i times I is 12i squared. I squared again is negative 1, so our answer is negative 12. And this one doesn't have your last problem. So 27, you guys have 3 plus 4i over 2i. We want to get rid of the I. There's no addition or subtraction, so we can just multiply by I. So we're going to multiply the top and bottom by I. I times 3 is 3i. 4i times I, 4i squared over 2i squared. I squared, remember, is negative 1, so that changes that sign. And I squared down here is negative also. So our final, our next one we'd have is 3i minus 4 over negative 2. Now if you got that far, that's great. But one thing you don't want is you don't want a negative here. So we got to change all of our signs. So this becomes a negative. This becomes a positive. That becomes a positive. So our final answer, reals first. So 4 minus 3i over 2. Final answer. Have a great weekend, guys. And if I were you, I'd download a blank copy of this and try it again.